Imagine for a moment that ChatGPT was never invented. No cursor or Copilot to help you write code, no Midjourney to help you generate images, no DeepL to assist in translating texts between different languages. The year is 2026, but AI is still just a dumb assistant, only capable of answering questions like, "What's the weather today?" If a group of researchers at Google hadn't published that specific paper in 2017, the reality we live in right now would be exactly like this. Today we talk about billion-dollar NVIDIA chips and trillion-parameter models, but not long ago, just 10 years ago, artificial intelligence had hit a massive wall. Our hardware was getting stronger, but our software was blind. It had no memory. It couldn't remember what happened 3 sentences ago. In this video, we will examine how the most critical bottleneck in engineering history was broken. It's not magic, it's just the right architecture. The source of the problem was the way we perceive time. Humans process words sequentially while speaking or reading. Josh went to work. When engineers designed AI, they imitated this biological structure. The result of this imitation was RNNs, or recurrent neural networks. The working principle of RNNs was simple. Take a word, process it, and pass the information learned from it as a legacy to the next step. Sounds logical, but there was a fatal engineering flaw here. We call this the vanishing gradient problem. Think of it like this. I'm reading you a 100-word paragraph. But we have a rule. Every time you hear a new word, you must forget 10% of the previous one. By the time you reach the end of the sentence, what are the chances of you remembering the subject at the beginning? It's near zero. Legacy AI models were exactly like that. Since the word France stayed at the beginning of the sentence, the model couldn't answer the question, "What language do they speak?" at the end. Because as the distance increased, the signal turned into noise. We were forced to process data sequentially. This meant that no matter how many GPUs you had, you couldn't parallelize the operations. You had to wait for the first word to finish before processing the second. There was no speed, no memory, no future. Then, in 2017, something happened. The paper "Attention is All You Need" was published. This paper is the Copernican revolution of AI history. The researchers proposed something bold. Throw sequential processing in the trash. Forget RNNs. They named the new architecture Transformer. Transformers do not read a sentence from left to right, word by word. They look at the whole sentence, the whole paragraph, even the whole book at the same time. They took time out of the equation and replaced it with space. Let's look closely at the mechanism. Here is our sentence. The man didn't cross the road because he was too tired. Our brain immediately understands that the pronoun he refers to the man. Legacy AI, however, would get confused. Was the road tired or was the man tired? The attention mechanism assigns a score to the relationship between every word in the sentence and every other word. When the machine reaches the word he, it looks back and calculates. The act of being tired is 90% related to the man and 5% related to the road. It does this not just for one word, but for billions of word pairs simultaneously in parallel. In engineering terms, the system works like a database query. We have 3 vectors: query, key, and value. Think of it like a library. You are looking for a book, and you have a topic in mind. This is your query. The labels on the spines of the books are the keys. You match your query with the key that fits best, and you retrieve the information inside the value. In the transformer architecture, this process happens billions of times per second, as massive matrix multiplications on GPUs. This is the technical reason behind NVIDIA's stock explosion. Transformers were the first architecture capable of fully exploiting the parallel processing power of GPUs. But this isn't just about faster computation or raw hardware power. When you scale this simple matrix multiplication to billions of parameters, something emerges that we didn't expect. The machine stops seeing words as isolated data points and starts perceiving the subtle threads of meaning that connect them across time and space. The attention mechanism didn't just give AI memory, it gave it context. The day we broke the chains of sequential processing was the day machines learned to read. If you are using AI today to write code, send emails, or learn new things, you owe it to that daring idea from 2017. Because in this field, progress isn't measured by luck. It's measured by the efficiency of your architecture. We analyze the gears behind the intelligence because understanding the math is the only way to master the future. This is Axiom Tech. We don't believe in magic. We believe in engineering. In the next video, we'll look at how this brain is trained. Stay tuned.